Hey guys, today we're going to look at side splitter theorem and the triangle-angle-bisector theorem as we continue our chapter on similarity and our consecutive sections on similarities in triangles. It's going to be really important for us to pay attention to what lines we're actually given, and I'm going to try to make sure we avoid some of the pitfalls that happen with this section, especially butted up against our similarity and right triangle section. Okay, so let's start. A lot more text in these notes, so that should help you out a little bit as far as being able to just pay attention and not write as much. But you should have seen that in the previous section we've learned that if two triangles are similar, then their corresponding sides were proportional. And so if we look at this triangle given to us, triangle QXY and triangle QRS, okay, we should see that these two triangles are similar by the angle-angle similarity, because we have the parallel lines here. And so since these lines are parallel, we should be looking for alternate interior angles, corresponding angles, same side interior angles, but I do see corresponding angles. Okay, and I see that angle QRS corresponds with angle, let's say QXY. Okay, so those angles are corresponding. I could do the same thing over here with these two angles. Okay, angle QSR and angle QYX. They are also corresponding angles. Okay, so by angle-angle similarity, I can tell you that triangle QRS, or I guess I should say XQY, is similar to triangle RQS. Alright, and so then the proportion that we could use in order to solve, or that we would use if we were trying to compare these two triangles, we would say that QX, or XQ, corresponds with RQ. Right, so the way that we would write XQ over RQ is A plus B over B, because XQ is A plus B, RQ is just B, and then that should have the same ratio, those corresponding sides should have the same ratio as YQ over SQ, okay, and that would be CD over D. Alright, so if you remember back to our first notes on proportions, there's one proportion property that we haven't really used very much, and that property basically said if we had A plus B over B and C plus D over D, that it was congruent with the proportion without the plus B's and plus D's. The way that we explained it in class, just as we go through it, is that realize that B over B and D over D is just 1. Okay, so we're basically adding 1 to each side. If this were 1/2, or half of the fraction, whatever, if A was 0.5 and C was the equivalent of 0.5, we add it 1, it's still 1.5. Okay, and so what this does is it kind of simplifies our ratio. Instead of having a whole lot to do it, we kind of cut that off, and it gives us another proportion, an equivalent proportion that we'll be able to use a little bit more easily. Okay, and so in that proportion we have A over B equals C over D. Okay, that is called the side splitter theorem, and it just says if a line is parallel to one side of the triangle and intersects the other two sides, then it divides those sides proportionally. So let's look at this. Our first example, we have these lines parallel. Okay, so this is parallel to one side, intersects the other two sides. It means it divides these sides proportionally. So I'm going to say, okay, that means that y over 12, that proportion, should be the same proportion as 6 over 10. And so I'd have 10y equals 72, and y will equal 7.2 after we divide by 10. that not only works in triangles, but in the case where we just have some parallel lines intersecting transversals, it works as well. Okay, so if we look at this corollary, remember corollary is kind of just like a logical conclusion based off of things you already know. So if we know that this works in triangles, would it work if I said, okay, well, up to here is 12 and up to here is 10? Will we still be able to use the same proportions? Yeah, even though it wouldn't be a triangle if we didn't have it as a closed figure. Okay, so here we're basically dealing with the same thing without a closed figure. And the same rules apply. So here we see parallel lines, okay, intersecting transversals, and we should know that that means that these lines divide the sides proportionally, or intersect the sides proportionally. And so we can set up, well, 16.5 over x should equal 15 over 26. Using my calculator, 16.5 times 26 gives me 429. 15x when I cross multiply here. Divide 429 by 15, and x should be 28.6. Okay. Alright, so side splitter theorem, not too bad to use. Hopefully you understand why we're using it that way as well. Now here's the one that's a little bit more, it's not confusing, but it does get confused with our last section a lot. Okay, this is the Triangle-Angle-Bisector theorem. Okay, and it's a long name, but at least it says exactly what it is about. If a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. And so what that means, let's say that when we have a diagram here, this ray bisects the triangle, bisects the angle here. And so what this says is, okay, so if it bisects this angle, then what it does is it divides these sides, C and D, in the same manner, in the same proportion as it divides these sides. So let's look at an example. Example 3, it says in the figure below, angle 1 is congruent to angle 2. So I'm going to make my marks there. Those two are the same. And so what that means is, again, it's divided this side in the same proportion that it divided these sides. So I'm going to set up my ratio and say 10 over 12.5 should equal 9 over x. Making sure that I keep the corresponding sides together. I'll say corresponding sides together. Okay, and so now we solve it. 12.5 times 9 is 112.5. 10x. Divide both sides by 10, and we should find that x is 11.25. And we should always make a common sense check just to make sure that it makes sense, the answer makes sense to us. Okay, notice that here 12.5 is larger than 10. I should reject any answer where x is smaller than 9. Okay, if it cuts it in the same proportion, then I should know that this side will be larger than this side. X will be larger than 9. Okay, same thing that we have to do up here with these other two triangles. Okay, right? So 12 is larger than 10. I should realize that this should be larger than 6. Okay, 26 is larger than 15. I should realize 28.6 should be larger than 16.5. Okay, just a common sense check that you can use to make sure that your answers make sense in the end. Going to the other side. Some more challenging problems. Do a couple of these. Alright, so here we go. This is a challenging problem because if you notice, it has both of the things we just talked about all wrapped up in one. So let's start with x. I guess alphabetically it goes first, and I think I found a way to set it up. You can always pause it to try to do it on your own, remember that. So here we go. We have the side splitter theorem working here because we have two parallel lines. And so what I see here is that I should be able to say 5 over 3 should equal 6 over x. Okay, splits the sides proportionally because of the parallel lines. And so 18 equals 5x. X will be 3.6. So x is 3.6. Now that helps us out because kind of would like to know that in order to find y using the Triangle-Angle-Bisector theorem, right? So using the Triangle-Angle-Bisector theorem, I can say, hey, this side, 9.6, over that side, 8, should equal, again, the right side, y, over that side, 4. 36, 38.4 equals 8y. In order to find y, I'm going to divide both sides by 8. What will that be? 4.8. I'll check on my calculator to make sure that I'm not making a mistake here. 38.4 divided by 8. There we go. Okay. And so that's how we use both the side splitter theorem. We use the side splitter here and the Triangle-Angle-Bisector. Triangle-Angle-Bisector theorem. Okay? So both in action at the same time. Alright. And again, common sense check, just making sure we know that this works. This is 9, this is 8. Okay, so this is a larger side than that. That means y should be larger than that. Works out for us. Alright, in example 5, it's printed out a little funny. Should say parallel. Okay, so HG is parallel to ED, which is parallel to BC. Setting up that side splitter theorem, even without a triangle if we didn't have one. And they want us to find x, and they want us to find y. So looking at this, here's how we're going to do this. I'm going to use a triangle to find x. I have this triangle AED with HG going through it. And so I can definitely use my side splitter theorem, not even the corollary here. And so I should have 6 over x equals 7.5 over 12. Cross multiply, 72 equals 7.5x. Almost 10, but not quite. So 7.72 divided by 7.5 gives us 9.6. So x is 9.6. Okay. Now I can find y a couple different ways. What I'm going to do is I'm just going to say that it should split these sides. Since I found x, I'm pretty confident in my answer is 9.6. I didn't have to round it or anything, so I'll use it. Okay, I'll say it should split these proportionally, so I'll say 9.6 over 4 should equal 12 over y. Okay, so 9.6y equals 48. That's 5. So y is 5. Just check to make sure I'm not messing up on camera. 48 divided by 9.6 is 5. Oh, guess I should have done that work down here. Find y. Okay. Alright. Now the question is, does AM bisect angle BAC? Explain how you know. So it's a tough question, kind of, and not tough in the sense that it's hard to figure out, but it does kind of sum up what we've talked about today. And so we should know that if AM bisects angle BAC, so AM here, AM angle BAC, if it does bisect, what does that tell us? That tells us that it splits this side in the same proportion, or proportionally to how it splits this side. And so if we look at BM and MC, they are the same. So AM does bisect it if AB and AC are the same. So let's see what they are. That's 17 plus 7.5, which is 22.5. So AC equals 22.5. This is 15.6 plus 4. This is 19.6. Okay, and so if we set up our ratio, 19.6 over 22.5 does not equal 5 over 5. So, does AM bisect angle BAC? No. The sides are not bisected proportionally. Say that. Proportionally. Okay. Hopefully I spelled it right. Hopefully that's a word. Proportionally, proportionately. Alright, last problem. Looks like a fun one. Trying to find the value of x. And just a bunch of x's. Okay, so we're going to use the corollary to the side splitter theorem. Should be pretty simple right now, and when they set up like this, it just looks like they already set up our problem. They should split proportionally. So x over 4x plus 3 should equal x minus 3 over 3x minus 1. So we cross multiply. 3x minus 1 times x, 3x squared minus x. X minus 3 times 4x plus 3. I'll work that out here because that's a little bit more math. 4x squared plus 3x minus 12x minus 9. Okay. So we have equals 4x squared minus 9x minus 9. And then looks like we're going to have to solve a quadratic. So let's move everything to one side. I'm going to move it all over here. And that'll give me x squared. Add x to this side. Minus 8x minus 9 equals 0. Okay, a couple different ways you can do this. I'm going to factor this problem. I'll try at least. And so one of the ways that we could factor, especially when a is 1, say is 1, we can try to find two numbers that multiply to give us this number and add together to give us this number. Okay, and those two numbers popped up in my head. I can see x minus 9, x plus 1. Okay, so minus 9 plus 1, negative 9 plus 1 is negative 8, negative 9 times 1 is negative 9. Works out, proves that point true. And so now we use a zero product property, which just says if we multiply two numbers and their product is 0, means one of these, or at least one of these two numbers, has to be 0. So we're going to solve to see what x could be to make this true. Well, if x minus 9 equals 0, that means x is 9. If x plus 1 equals 0, that would mean that x is negative 1. So here are two possible values. Now, I circled that, but let's look. Are there two possible values? The answer is no, because since we're talking about length of a side, this side comes out to be negative if x is negative 1. Okay, it's okay to have a negative number if it comes out to be a positive length, but in this case it comes out to be a negative length, actually in a couple cases here. Okay, and so that is not a possibility. The value of x is just 9. Alright, hope that helped out. See you Thursday.